Hi everyone. Before we get into the code and simulation of the robot, I first wanted to demonstrate its searching and driving algorithm using this ultrasonic distance sensor. So on our robot, we'll set a sensor just like this one, but it'll have a camera at the top and two servo motors at the bottom. The two servo motors at the bottom will allow the robot to look left, look right, and look up. When the program first starts, it'll check for humans. It'll look in front of it and check, look up, check, look to the right, check, look up, check. It'll go back to its original position. It'll look left and check. It'll look up and check, and then go back to the original position. If no human is found at that point, the robot will then start its driving loop. It'll check in front of it for obstacles. It'll check to the right for obstacles, and it'll check for the left for obstacles. Based on the obstacles found, the robot will then choose to turn left, turn right, go forward, or go backwards. It'll cycle between this driving and searching state until a human is found. Moving on to our Tinkercad simulation, we have three servo motors. This servo motor here will control its ability to look up. This servo motor will control its ability to look left and look to the right. And this servo motor will be used to actuate the touch arm. We have an ultrasonic distance sensor, which will be used to detect obstacles. We have a photoresistor, which will be our fill-in for the camera, which will detect humans. And we have a piezo, which will be used for our speaker. Here we have two DC motors, and those are powered by this 9-volt battery and controlled by this motor controller chip. We have an IR sensor, which will be used to read inputs from the IR remote. We will now simulate our code, and once we start the simulation, the servo motors will go to a default position. We can then use the IR remote to select a number 0 through 9, indicating how many hours we would like to sleep, 0 representing 10. If we were to input something that wasn't a number, like volume negative, it would play a sound and say invalid input on the console. So let's select 5 hours of sleep for our robot. It'll then count down from 5 hours, and these are in seconds. And once that starts, the alarm will start. It'll then begin searching for a human, looking up. It'll look to the right and check. It'll look up and then check. It'll go back to center. It'll then look all the way left and check. It'll look up and check. And then it'll look forward. It'll then begin checking for obstacles, and because there wasn't one found, these two DC motors activate, driving it forward. If we were to place an object right in front of it, and because this sensor isn't actually moving left and right, it'll detect an object on all three sides, forward, left, and right. So once it finishes its searching algorithm, it'll then begin its driving algorithm again. So now it's looking up, checking for human, looking up, checking for human, and then it's going to look forward and check for obstacles. Because it found an obstacle in front of it, it's going to look to the right and check for obstacles, which there still is. It'll look left and check for obstacles, and there still is. And because there's no clear path, it'll say no clear path and begin reversing. To find a human, we'll just actuate this photoresistor here all the way, and because we found a human, it'll start articulating the touch arm. This touch arm will continue to articulate until the user presses the power button. Once the power button's activated, it'll say user awake, good morning, terminate the program, and return the servos to original position. We will now look at the programming of our robot, and essentially it's just a bunch of functions that work together to perform complex tasks. Feel free to pause or stop the video at any time if you'd like to have a closer look at these various functions. The first one we passed here is the IR remote function, which checks the input of the remote and produces a countdown output and starts the find human function. The next function we'll pass is the search. This will return an integer and check if any humans are available. We will then pass our looking functions, which can look left, right, and center. These are our driving functions, which can tell it to turn left, turn right, drive forward, and reverse. Now we have our Boolean obstacle functions, which return a Boolean value if there's an obstacle on the left, right, or center. We have our check IR function and the end of our program.